What's up, everybody? It's Travis here from Travis.media. Today I'm going to teach you developers how to develop decentralized apps on the blockchain by example, by building a simple app together. So number one, this is for developers. So if you're a developer, you should be able to follow along. If you're like, I don't even know what a variable is, then this may not be for you. But you make that call. You might be able to follow along by just knowing a little coding, but that's going to be assumed. Second, the reason I'm creating this video is because when I started learning, there were so many tools I didn't know where to begin. There's Hardhat, there's the Truffle suite, there's Web3.js, there's Ethers, Solidity, Vyper, the Rinkeby network, all of these tools, and I'm like, where do you begin? How do you piece them all together? Where do you start? What are their use cases? That's why I'm creating this video. Now that I've worked with these tools, I'm going to break them down for you. We're going to work through them and create a smart contract and a front end to interact with that smart contract and the blockchain. And there's going to be two parts. The first part is going to be focused on Hardhat.js, which is going to bootstrap this project for us so that we can create a smart contract, compile it, test it, and deploy it. And the second part is going to be looking at Ethers.js, which is a package to interact with your smart contract and blockchain. And we're going to build the front end of the app with react.js. So hopefully by the end, you'll feel more confident about these tools and be able to take them and use them in your own use case. Hope you enjoy the video. Let's get started. So I'm going to cd into my desktop, and I'm going to create a folder called blockchain-demo. And then I'm going to cd into that and open it in VS Code. And to kick off this project, we're going to look at a package called Hardhat.js. So open up a browser and just type that in, hardhat.org. And then on the home page, just click on this Get Started button. Now, as we mentioned, Hardhat is a development environment to compile, deploy, test, and debug your Ethereum software. It's a huge part of this whole blockchain process. I mean, think about it. You got the front end with Web3 or Ethers.js, whatever you use, and everything else is within this Hardhat ecosystem. And when we bootstrap it, you'll see here in a minute. And the first thing we want to do is install it. So copy this npm install command. Open up your project and your terminal. And before we do that, just make a directory called contract, cd into it. And then let's do an npm init-y command to create a package JSON so we can install npm packages. So if we look in the folder, we now have a package.json, and then let's run the command to install Hardhat. Next, we're going to bootstrap the project. So if you look under quick start, we have a command npx hardhat. So let's run that. I'm going to paste that in. And it's going to ask us, hey, what do you want to do? We want to create a basic sample project. There's some other options, some advanced options, but we're going to choose this basic sample project. We're going to keep the project root. We do want to git ignore. Then it's going to ask us if we want to install the project's dependencies. So to bootstrap this, you need a few more packages. So you'll see here Hardhat Waffle, Ethereum Waffle, Chai, Hardhat Ethers, and Ethers. These extra packages make Hardhat compatible with tests built with Waffle, which is a simple smart contract testing library. And Ethers.js is a JavaScript library that allows you to interact with Ethereum. That's all these packages do. So once we bootstrap this, you'll see that we have testing, we can deploy, we can write our contracts, and all that other good stuff. So hit enter to install those extra packages. All right, and now you see in this contract folder, we have a bunch of stuff now. So we have a contracts folder, which has our greeter contract. This is the default with this project and what we're going to be deploying today. We have a scripts folder, which has a deployment script in it we're going to look at, and it has a test, a sample test. We're going to look at that also. Also, there's a Hardhat config. You can configure your Hardhat environment here. And then, of course, the package JSON we've already looked at. If you look at the README, it's going to give you a bunch of commands that you can run, but you can also do npx hardhat to look at them. So if we run that, we see these available tasks. Accounts prints the list of accounts that it provided us. So we can do npx hardhat accounts, and it's going to show the accounts that it provided. We can run the compile command to compile our smart contract. We can run test to test it, and node to run a node. We'll see all that in just a minute. So let me clear the screen. So first, let's take a look at the contract, the default contract. So it's called greeter.sol, and it's very simple. Basically, when you deploy it, you're going to give it a greeting, and it has two functions. One's called greet that returns a greeting, and the next one's called setGreeting that allows you to change that greeting. I'm going to create another function here just to make it a little more enjoyable called deposit, and it's payable and public, and you don't have to put anything in it. This allows us to deposit Ether to our contract, which we're going to do. And we're going to display it on the page. Now, if you're looking at this and you're like, oh my goodness, what is this? I don't know Solidity. Well, you can get up to speed pretty quick since you are a developer. Now, I tried to look on YouTube for free videos, but they were either outdated, too short to get anything out of, or too much extra technology, like all this front end and all this other stuff you don't need outside of Solidity, or to learn Solidity specifically. So I wasn't able to find anything, but I did find, when I was learning Solidity, a Udemy course that I thought was really, really good. And it's called Master Solidity Programming Udemy. I'll put a link to this below in the description. Yeah, from scratch in 2002. I took this course not too long ago, and it was really, really good. It takes you through all the Solidity basics, a bunch of challenges, and it gives you 5 projects here. So the lottery smart contract, the auction. So you got a lottery, you got an auction, crowdfunding, implementing an ERC20 token, and then a ICO. I've only done the first 2. I haven't even gotten to 3, 4, and 5, and it was really, really valuable. There are some other Solidity courses on Udemy. Reading the reviews and stuff, they looked outdated, and they looked like they didn't cover all the things I wanted to cover, or maybe it was too long or whatever. I just like this course. It's like, I think 9 hours. Yeah, 9 hours on demand. So if you don't know Solidity and want to learn it, just buy this course. Take 9 hours. You can take a week to learn it, a couple hours a day. And you'll come out of this course knowing Solidity pretty well. Again, I'll put a link below in the description. But this is it for our contract. Now we want to compile it. So to compile it, you just do npx hardhat compile. And what that's going to do is that's going to create an artifacts folder. There it is, artifacts. And if you open that up, what we're interested in is this contracts folder. And within that, there's a greeter.sol folder. And there's a greeter.json within that. If you click on that, there are 2 things we're interested in. First is the ABI. So the ABI is what we're going to give to our front end that basically tells it about all of our functions and allows it to call those functions. So here's the ABI, and you'll see it has the setGreeting and the greet function, and it allows us to interact with it. So that's the ABI. The other thing is the bytecode. So this bytecode is what's deployed on the Ethereum virtual machine. So when we deploy our contract, this bytecode is going to do its thing. We'll look at all that in just a minute. And that's it for our contract. We added one function called deposit. I think that was in the ABI. Greet. No, it wasn't, because we didn't save our smart contract after adding the deposit. So let's save it, and we're going to compile it again. Compiled one Solidity file successfully. I'm going to click on greeter.json, and then we should have a deposit command now. There it is. Deposit. Okay, we're good. Let's close that out. The next thing we want to look at is the tests. So we wrote our smart contract. We feel good about that. Now we have to test it. If we open that and go to sample test, you'll see that they've supplied us with one test already. And the reason why you want to test, of course, is you cannot alter a smart contract once it's deployed. So you want to make sure you test it good. So if we look at this sample test it gave us, it says it right here actually. It should return the new greeting once it's changed. So when you change the greeting, so you have a greeting and then you change it, and then you check again, it should be changed. That's basically all it's doing. Here it's creating the contract object and deploying it virtually. And it deploys it with the greeting of hello world. So there it is, that's deployed. And then it's expecting, so it's running this greeter.greet function. It's expecting that that equals hello world. So you deployed it with hello world, you run the greet function, it should return hello world. And then we're going to run the greeter.setGreeting function and change it to this hola mundo text. So that's set, and that saves it in a variable, set greeting transaction. And here, we're going to wait until the transaction's mined. And then the second expect statement just expects the greeting now to be this, hola mundo. And that's it. So we deploy it with a greeting. We expect it to have that greeting. Then we use the set greeting function to change it to something else. Then we check it again, and it should be that changed greeting. So if we want to check that this test works, we can just do npx hardhat test, and it should pass. There it is, one passing. So this works. Now we want to add one more just to check the deposit function. So when we deposit something, we want that balance to reflect the change. So let's copy this and just paste it below. Actually, I can just do that. And we'll change it to, it should return the new balance after Ether is deposited. And I'm going to keep this here. Actually, we can pull that above it. If we have a bunch of tests, we can put that above it so we don't have to keep writing the same code over and over, but we're just going to have two tests. So I'm going to leave that there. And I'm going to erase this. So we know that our contract's going to be 0 when it's deployed. So I'm going to run this await greeter.deposit. Then I'm going to put in here the value is going to be 10. So we're going to deposit 10, and we need to check now that the balance is 10 also. And to check our value, we can use something called the provider, which we're going to talk about in a minute. But for now, we're just going to put const provider equals waffle provider. And then we can do simply provider.getBalance. Actually, we want to make this expect. And of course, await provider.getBalance. Our contract object, which is greeter.address. So we're going to get the balance of the contract address. We'll put 2 equal 10. All we're doing here is we're saying, hey, the contract was deployed with 0 Ether. Now we deposited 10, and we expect now that the contract balance is equal to 10. Very simple test. If we run this command again, we should have 2 passing tests. Yep. Great. So that's it for testing. You can add more tests if you want to build on your contract, whatever you want to do. Testing's pretty easy. So let's close that out. So we've looked at the contract, we've compiled the contract, we've tested it successfully, and the only thing left is now to deploy it. So we have this sample script that allows us to deploy our contract. It's a bunch of comments in there for you to read. It's pretty straightforward. Now to deploy the contract, let's go down here to deploy. You just run npx hardhat run and then this scripts file. And that's going to deploy an in-memory instance of Hardhat network. So that's cool and all, but a better way to do it is to start up a Hardhat node. And it says right here, it's also possible to run Hardhat network in a standalone fashion so that external clients can connect to it. This could be MetaMask, which we're going to be using, your Dapp front end, which we're also going to be using, or a script. To run Hardhat network in this way, just run npx hardhat node. And that's exactly what we're going to do. So let's run npx hardhat node. There we go. Look at this. I have 19 accounts now, actually 20 because it starts with 0. This supplies us with 20 accounts and private keys for those accounts. Now these keys I think are the same for everybody when you run this in Hardhat. So of course don't use this in production, but it's great for development. And you'll see that this node is running. See, we're not back at the prompt. You'll see that this node continues to run. So anything else that we do, we need to open up a new terminal. But what we can do now is now that we have all of these accounts, let's grab one of them and go ahead and set up MetaMask. So I'm going to open up Firefox. Chrome is what I use my main MetaMask in. Firefox is what I use for MetaMask testing. And I've deleted it for now. So we're going to go through how to install it and set it up. So if you type in MetaMask and go to download and install MetaMask for Firefox and add to Firefox, we're going to install this Chrome extension. and set it up to work with Hardhat. So once that's done, just hit add. And we're going to walk through the setup. So click get started. And I'm going to set up a new wallet. This is just testing. You shouldn't have any secret recovery phrase for this. Create a wallet. I'm going to hit no thanks and set a new password. So type in a password. Agree to the terms, hit create. Hit next. And then they have this secret recovery phrase. I'm going to click on it, and I don't really care to keep this because this is just for development. If it messes up, I can just wipe it again. So I'm going to copy this, put it up here, and use it for the next step, which is recreating this. So let's see. What you're doing here is you're just typing in these words that they gave you in the same order. All right, all the words are there. Hit confirm, congratulations. Okay, so our node is running. Check to make sure your node's still running because you won't be able to set up this network unless it's running. So scroll down, yes, my node is still running. So next, go up to Ethereum mainnet, click show and hide test networks. You want to show the test networks, so turn that on. And go to add network. Actually go to networks over here and just delete this one. I don't want that one. And we're going to create a new one, add a new network. We're going to call it localhost 8545. RPC URL is going to be http localhost 8545. Chain ID is going to be 31337. Currency symbol, I'm going to put ETH. And after you got all that, just click save. And you'll see here you're now on your localhost network. And we need to add an account. So if we go back to Hardhat, let's grab the first account here. So account 0, let's choose the private key. And then go to, where is it at? Import account. So click import account. Select type private key and paste in your private key. Click import, and there you have it. 10,000 ETH to work with. Now I like to change my account details, change this account to Hardhat account. Hit the checkbox, and there we go. Great. So now we have a MetaMask account to work with. And finally, we have our node running. We still need to deploy our contract. So if we go to another terminal, go back to the contract folder, go to our Hardhat documentation and scroll down, you'll see this command, npx hardhat run. So it's going to run our sample script, but it's going to choose the network of localhost. So it's going to deploy our contract on our localhost, which is our node that's running right now, our Hardhat node. So select this and let's run it. Hit enter. And it should deploy it. Yep, greeter deployed to this contract address. So take that and copy it and put it somewhere. I'm just going to put it in my README here for the moment and save that. And guess what? That's it for the back end. And do you see the power of Hardhat? It gives us everything we need to write a new smart contract, to test it, to deploy it, and all that stuff. So feel free to tweak your contract, do whatever you want with it, or you can continue with me as is, as we're going to move on now to the front end. So now we're going to begin the front end of the app. Be sure that your Hardhat node is running still and that you've deployed your contract, which we should have done in part 1. Just wanted to note that. So let's go out of our contract folder, so cd ... and we'll do npx create react app client. This is going to deploy a new create react app in a folder called client. So just hit enter. Once that's done, cd into it. And we're going to remove some stuff. So close out the contract folder, open up the client folder, go to source, and let's delete some stuff. We're going to delete setup tests, report web vitals, logo, the app test.js, and the app CSS. So highlight all of those, right click, and delete. All right, and then we need to remove a couple of references. So go to app.js, remove the logo, up top, the app CSS. For the function, we're just going to remove all of this and just return an h1 that says hello, save it. And then index CSS, index.js, let's remove the report web vitals and this part down here, report web vitals. And that should do. Now if we do npm run start, see if our project builds. And there we go, we have hello. So for this project, I'm going to use Bootstrap. I don't use it a whole lot, but it's just going to make it a little easier for us to get things up quick. So we're going to just build the app real quick, like the UI. It's going to be really simple. And then we'll jump to the Ethers.js package and working with our smart contract. So let's go to Bootstrap and download. And we should find an npm install Bootstrap. So copy that and run it. So stop this app and install Bootstrap, npm install Bootstrap. We can come to our index.js, and at the top above the index.css, just type in import bootstrap /dist/css/ bootstrap.min.css. That's going to give us access to the Bootstrap library. That's all we need to do there. So like I said, I don't use Bootstrap a lot. So let's go to layout, containers. What do we want? Container, we don't want fluid, container. So let's go to our app.js. So we're going to do this whole thing in app.js because sometimes, trying to make it all clean, it gets super complicated, and we're trying to keep this simple. So right here, we're going to return this container. And inside of that, we're going to do some columns. So we got to go to grid. And let's just copy this. And paste it. And we have a row, and we have 3 columns. So we don't want 3 columns, let's do 2 columns. Let's just say column 1 and column 2. Hit save. Let's run our app to make sure this is working. Yeah, column 1 and column 2, good. All right, so the first column, we're gonna put let's do an H3 that says greeting, and then we're gonna have a paragraph tag that says contract balance is 0. We'll fill this in with dynamic data later. And over here, we're gonna put 2 forms. One to deposit Ether and the other to change the greeting. So let's go back to the Bootstrap documentation, go to forms, find a simple form. Here we go, this looks good. So let's grab that. We're going to put a form here. Let's kill the label. And with JSX, we have to have a closing tag with a slash, self-closing. And really, I don't want all that. We're just going to have one field. So let's erase the other 2. Input, div, we don't need a div. The type is going to be number. ID, I don't care for an ID. I don't need that either. Let's do a placeholder. And a value equals, just put test for now. Then I'm going to take this, well, there's a button, type submit. Let's put deposit. So that's our deposit form. Let's copy this, and right below it, let's put another form. This is going to be a text placeholder. Let's do your greeting. Actually, I don't even want a placeholder for that. And the button is going to say change. So let's see what that looks like. And actually, let's do button primary. Let's do button success and button dark, just for a little color. There we go. So that's all crammed up at the top. Let's put some margin here. So row, CMT5, margin top 5. And then our forms, class equals margin top 5. Let's see if that helps any. Yeah. That's good enough. So we have our greeting, which just says greeting. We have our contract balance. We have a form to deposit ETH and a form to change our greeting. And I think that's the UI. That's what we're going to use because we're looking more at functionality here than we are style, because we're trying to learn how to do blockchain development, not CSS. Okay, so the package we're going to use here that's going to give us all the functionality we want is Ethers. So stop your project and do npm install Ethers. What is Ethers? Let me open it up here because we're going to need to reference the documentation. And go to getting started. So go to ethers, docs.ethers.io, v5 getting started. That's where I'm going to work at. So we installed Ethers, npm install Ethers, and we need to import it at the top. So we're going to do that in our app.js. And by the way, let's go ahead and just import React. We're going to be using use state, probably use effect from React. Good. And before we get into the Ethers part of it, let's go ahead and make our UI functional. So in the first form here where we are going to deposit Ether, let's do an onChange. Handle deposit change. And then down here in our second form, let's do an onChange. Handle greeting change. Let's create functions for those. So there's our handle deposit change. Let's copy that down. Handle greeting change. And let's set some state up here. So const, let's put greet, set greet. And I'm doing that because remember our function in our contract is set greeting. So I don't want to put set greeting here too. So I'm going to put set greet. And that equals use state. And let's just keep it blank. And then down here in our value for the greeting, let's put the value of greet. Nope. And let's do another one to handle our form values. So const greeting value, set greeting value. And then another one for the deposit value and set deposit value. And then down here for our value, we're going to put just what we put up there. We're going to put deposit value. And then down here, we're going to put greeting value. And then in each one of these handle changes, we're going to put an E here. And we're going to do set deposit value, e.target.value. And oops. Then down here, we're going to do set greeting value. And let's go ahead and run the app after doing that and see if things are working. So I can use here the React developer tools. So if you download that Chrome extension and go to components, see your app component, you should see a change here when I start typing. Yeah, so see the state changing to whatever I type. And then the deposit, if I put a 3, it's going to change to 3. If I put a 4, it's going to change to 34. Cool. So we're capturing the state when we type into the input fields. Now when we submit this form, we need to grab whatever that state is and make it available to send to the contract. So to do that, we need to go to the form and do some onSubmits. So this is just basic React. on submit, and down here on submit. For this first one, I'll call it handle deposit submit. And for the next one, I'll call it handle greeting submit. And we want to create the functions up here. And of course, we want to e.prevent default so that it doesn't submit the form and refresh the page. Let's do that for both. And then I just want to console the value. So that's going to be console.log. And up here, remember, we're setting this deposit value state. So that should be available for us to use. So deposit value. And then down here, console.log. Greeting value. So let's try that out. Uh-oh, E is not defined. Let's make sure we put an E in here for our event. Save it, everything looks good. Refresh the page and let's try it. 3. We go to back to my console. Invalid DOM property class. Yes, we copied everything in. We got to change all of the classes to class name. So in VS Code, if you select the class and equals and just do Command D and select all the instances of class, then you can change it to class name, which will make React happy. Refresh and we have no errors. So if I put 15 here and hit deposit, I should see it in the console. Yep, 15. And this is a new greeting. Hit change. Yep, this is a new greeting. So now I think we're all set to start using Ethers and interacting with their contract. So let's refresh the page. All right, so again, if you go to this docs.ethers.io getting started, you'll see we've already installed the Ethers package. We already imported Ethers into our app.js file. And let's go down here. Connecting to Ethereum, MetaMask. So we want to connect to MetaMask. When our app opens, we want to connect our MetaMask wallet. And it gives us a great example right here. And before we do this example, let's talk about the provider and the signer. So up here it says, a provider is a class which provides an abstraction for a connection to the Ethereum network. Here's what's important. It provides read-only access to the blockchain and its status. So you can use the provider to read from the blockchain. It's read-only. It provides read-only access to the blockchain and its status. That's the provider. Now the signer is a class which usually in some way directly or indirectly has access to a private key which can sign messages and transactions to authorize the network to charge your account Ether to perform operations. So the provider's read-only. It can read from the blockchain and its status. Cool. Then there's the signer. The signer has access to the private key and can actually make changes or create transactions on the blockchain. So just keep that in mind. So connecting to Ethereum, a connection to the Ethereum network is the provider. Holds your private key and can sign things, a signer. That's what we're getting down here. Let's copy this. And let's paste this in. Up here at the top under the states, let's paste that bit of code in. The provider, const provider, new ethers.providers.web3 provider window.ethereum. So the MetaMask is actually an object, window.ethereum, in your browser. So we're creating this provider, and from that provider, we call a method to get the signer. So we have a provider object and we have a signer object. Cool. Let's delete all these comments. Let's delete this up here. Let's put the provider and signer together. And then we'll deal with this down here. So right here it says MetaMask requires requesting permission to connect user accounts. So if you haven't connected your MetaMask wallet, it's going to ask your permission the first time you open it. So we of course want to do that in a use effect because we want to call it once the page is loaded. So let's do use effect. Let's move this into our use effect. So it's going to call this once the page loads, or the component loads. So await provider.send ETH request accounts. And of course, you can't use await inside of use effect. So let's create a function. Const connect wallet. And let's make that async. Let's move this up. And we'll call it down here. Connect wallet. And we'll do a catch. We'll do console.error. Great. So when we first bring up the app, it's going to ask us to connect via MetaMask. Let's try that out. Oh, is my app running? Yeah, it's running. Let's go to Firefox because that's where I have all my test accounts at on MetaMask. Localhost 3000. And look at that. So we open the web app and it says connect with MetaMask. And of course, I'm going to connect my Hardhat account. Remember the one we created in part 1? Make sure that one's checked and hit next and connect. Great, my wallet is connected. So that's connecting to Ethereum, MetaMask, via MetaMask. There's some other examples here like connecting RPC, querying the blockchain. So for instance, you can get the balance of the contract, which is something we do want to do. So I'm going to go ahead and copy this plus this formatting here. We'll talk about that in a second. And I'm going to create a function under this called const get balance. Make it async. And let's paste that in. So const balance, await provider.getBalance, and we want to put our contract address. So let's go back to, I think we put in the README, or it's the README in the contract folder. Remember we pasted the contract address in here. You might have put it somewhere else. I put it here just for safekeeping, or not so safekeeping. But anyway, let me cut that or copy it into my clipboard. I'm going to come up here and do const contract address. This is the address to my deployed contract. And I'm going to put that in here instead of the Ethers.eth wallet. That's going to provide us with a big number. So it's going to be this crazy number, and we want to format it using some of Ether's utils functions. So ethers.utils.format ether balance. This is going to give us what we're used to seeing. Like if you have 1.3 of Ethereum, then you want to see 1.3, not like this long number. So let's put that there, and let's just actually, we'll just go ahead and set it up. So let's do set greet. Remember we have this state up here, so let's do set greet, and we'll do const balance formatted, and we'll do set greet balance formatted. And then down here, well, let's call it. So after we connect our wallet, we'll do get balance dot catch console dot error. Since we're setting the greeting, we can use greet down here for our greeting. Greet. Let's save it. And we have 0.0. So if we add something here, we should see this go up because we're using the provider to get our contract balance. If I wanted to take my MetaMask wallet and copy the address and put that in instead, I should see 10,000. So instead of my contract address, let's put my wallet address. And there it is. I don't quite have 10,000. I must have spent it on something. But yeah, 9999 Ether, which I wish was true, but of course it's not. And by the way, I made a mistake. You guys probably already noticed it. But up here, instead of set greet, we actually need to set. So instead of set greet, we need to create one for our balance. So let's go up here and do const balance. Remember this deposit value and greeting value, that's from our forms. So this is going to be our greeting. This is going to be our balance. So set balance. equals use state. And actually, let's take the 0 out. We don't want to put a 0 there. And we come down here, instead of set greet, we want to set balance. And then down here, we can set our balance here. So we put balance to display our balance. And that greet we haven't put together yet, so let's put greeting back the way it was. And save it. And now when we open up, we should see our wallet balance. So everything's working. Let's set that back to our contract balance. Or our contract address. Hit save, and there we go. Our contract balance is at 0. We haven't done anything yet. Our greeting is here. Now let's make our forms work. And just a note, that's querying the blockchain, so you use the provider to do that because that's your read-only connection. Writing to the blockchain, you're going to want to use the signer. So like right here, signer.send transaction. That's how you would use that. But what else you want to do is you want to create a contract object so that you can communicate directly with your contract, right? So you want to be able to call the greet function. You want to be able to call the set greeting function and the deposit function. You can't do that just with the signer and provider. You got to create a contract object. It actually says it right here. The contract object makes it easier to use an on-chain contract as a normal JS object with the methods mapped to encoding and decoding data for you. So to do that, we need a couple of things. And it probably tells us down here. Yeah, here we go. Just follow the documentation. So let's copy this. And I'll walk you through it. So under contract address, let's just take this, paste it in. We have our contract address. We can delete die address. So everything we're going to use is like die something. We're not working with die. So let's erase that. The first thing you need is the contract ABI. Now we talked about that in part 1. The ABI is the human readable format for you to talk to your contract. So it includes all of the functions that your contract has so that you can call those functions. So like right here, the ERC20 contract ABI, which is a common contract interface for tokens. This is the human readable ABI format. So let's erase that. And I'm going to rename this to just all caps ABI. And that's going to be back in our contracts folder. Go back to your contracts folder in your artifacts and your contracts and your greeter.sol folder and greeter.json. Remember we looked in here earlier? Here's your ABI. So grab this whole array down to the closing bracket, copy it, come back to your app.js and replace what's there with your ABI. All right, so now we can call these functions that exist on our smart contract so that we can interact with it. The last thing you need to do is you need to create the contract object. And I'm just going to call that contract. That's new ethers.contract. The first argument is the contract address. The second one is, of course, the ABI we just created. And then instead of provider, we're going to use signer because that's how we're going to be using it. So save that. Now check this out. Now that we have this contract object, we can come down here and say const get greeting. And we can do this. Let's do const greeting equals await contract dot what? What do you think we'll do? Well, we want to get the greeting. And if we look in our contract, that is a function called greet. Takes no parameters and it returns the greeting. So right here, we'll do contract.greet. That should get our greeting. And then of course we want to set that. So right here, set greet. Set greet, greeting. Now this should grab the greeting that we deployed, which I think is like hello world or something. It should grab that, and then down here, well, let's call it get greeting. Catch console. So down here, instead of this hard-coded greeting, now we can just put greet. And it should reach out to our contract and grab the current greeting. So save that. And there we go. Hello, Hardhat. That's what we deployed. Hello, Hardhat. All right, so we're getting the greeting. We got the contract balance. Now we need to make these two things work. So let's work first on let's do the greeting first. So let's go to our handle greeting submit function. And we want to do this. So let's make it async. We want to do await contract. And what do you think this is going to be? Of course, set greeting, because that is the function here. Function set greeting. It takes a string of greeting and sets the greeting. So contract.set greeting. And the greeting that we're passing in is, of course, greeting value. Remember, we're setting that up here as we type. So set greeting value. So this call is going to change our greeting. And then we need to change this greet message on our home page. So right here, where we're displaying the greet, we need to change that. So we need to do set greet, greeting value. And then, of course, we don't want to leave that value in the, well, actually, I'll just show you. So let's save that and try it out. So let's refresh just for kicks. All right, so this is a new greeting. Now, when we hit change, because we're interacting with the contract, it should open up MetaMask and ask us to pay the gas fees and all of that. Well, this is a test wallet, so of course we're not paying any real money. But let's go ahead and try it out. So click change. It's going to bring up MetaMask. And we hit confirm to update this transaction. So confirm. Now that didn't work properly. Why? Because when you create a transaction, you need to put something in there to wait until the transaction is done before doing the next thing. So locally, it only takes a split second. On a test net, it takes forever. And then, in production, it can take 5 to 15 seconds. So let's go back to our code and fix that. So here we want to put a const greeting update. We want to put that into a variable. And then we can do this thing with Ethers called await greeting update dot wait. And what this is going to do is it's going to wait until the transaction's complete before it runs the next thing, set greet. So let's try that out, save that, come back up here, and let's put something else. Hello, Travis, instead of Hardhat. Let's hit change, brings up MetaMask. Let's confirm the transaction, confirm, and boom. Our greeting has changed. Wonderful. Now, we don't want this text staying here. That looks kind of bad. We want that to go back to blank. So let's go back and fix that. So we need to do set greeting value. We need to set it back to nothing. So let's try something else. This is another greeting. Change, confirm it. This is another greeting, and our text is gone, ready to put something else in there. Great. So our decentralized app is interacting with this Hardhat network local node blockchain. So if we switch to one of these test nets like Rinkeby or something like that, it's the same concept. And we'll do that in another video. Right now I want to keep it super simple for time's sake. So let's work on the deposit now. So the greeting works. We're able to update the greeting. Now let's make it so we can deposit some funds to the contract. So let's see if we can find that. Handle deposit submit. So deposit value is the value we want. Let's try the same thing. Const deposit ETH equals await contract. Now what do you think we're going to put here? We're going to put deposit because that's their function in our smart contract. And what you can do here is you can put an object inside of this that says value is what? Let's do, of course, deposit value. Now, of course, this is not going to work due to the formatting. Remember up here, we had to do this ethers.utils.format ether. Well, now we have to do this parse ether formatting. And to do that, we'll just come up here and do eth value and ethers.utils.parse ether and deposit value. And again, this keeps us from having this big long number. I think it's in way, but we want to keep it in straight ether. We're going to format it first, and then right here we're going to put eth value. And of course, like we did with the greeting, we want to do deposit eth. And let's await that. Await deposit eth dot wait. It's kind of funny. And then that'll wait for the transaction to happen. So the eth is deposited. Then what do we want to do? We want to update our balance. So let's go up here just to make this easy. Let's just copy this here. So instead of just updating it on the page, we're going to actually have it call out and get the new balance after this is done. So let's paste these 3 lines here. So we're going to get balance, we're going to format it properly, and then we're going to set the balance. And that should be all we need to do. So save that. And there's an error in 103. We don't have an async on this function. So let's fix that and try it out. So we want to deposit 1.3. Click deposit, and it's going to, of course, bring up MetaMask. It's going to show us that we're depositing 1.3. And just click confirm. And look at that, our contract balance updated to 1.3. Let's put the symbol behind it. Let's put ETH. There it is, contract balance 1.3 ETH. Let's put here Travis's wallet. Change the greeting, works great. And then let's deposit another, and we do want that back to 0 after we deposit also. So let's do the same thing we did with the other one. Set deposit value, and we're not going to put anything in there. Let's try that change out. So I'm going to deposit another 0.234. Deposit, confirm. There it is, my balance updated. My number stayed there. Let's put a 0 here to see what it does. 0.12112. Confirm. Yeah. Okay, so it goes back to 0. So it's a number field. I guess it has to have something in there. Can't have it blank. So we'll just leave it like that. And I believe we're done. There you have it. So we have our wallet. We have a greeting that we can set out on the blockchain. We have a contract balance that we can actually deposit Ether to. And we can have it update here after each transaction. Congratulations, you just wrote a smart contract, you tested it, you deployed it, you created a front end with Ethers.js, and you have a fully functional decentralized app. Hope you enjoyed this tutorial. I'll see you in the next video.